Thanks for the invitation. And today's topic is urban spatial monitoring on innovative activities. We use a case of G60 Innovation Corridor in Yangtze River Delta, China, to showcase the system operation of urban spatial monitoring, especially using patents to as a proxy of innovation activities. And work is basically conducted by the postgraduate student Wang Lie from the College of Architecture and Urban Planning, Tongji University. And the overall research background, actually, we need to start from talking about urban spatial monitoring, and it actually plays a very important role in China's natural resource investigations and monitoring system, and is significant support for the construction of China's system. But current research primarily focused on the monitoring process. Very few actually giving attention to the application in assessing and evaluating the implementation of planning. And we view that monitoring innovative activities in urban territory space, especially in technology-intensive areas like the G60 Innovation Corridor, is very important for understanding the spatial dynamics of innovation. So here comes to the research. There are many innovation corridors around the globe, and in recent years, innovation corridors have gradually become the hotspots for planning and construction in countries around the world. Here we use some maps to showcase. For example, in Malaysia, we have the multimedia super corridor plan, and in United States, the very famous corridor, the Route 101, Route 128, and the Cascadia Innovation Corridor across Canada and the United States are very well-known innovation corridors for its intensive R&D activities. And there are many corridors thereafter follow the world-renowned innovation corridors. And also in China, there are many plans to initiate the regional innovative corridor. For example, here in Yangtze River Delta, we have the G60 Innovation Corridor, which actually locates along the G60 highways. And this corridor actually has undergone a very important and continuous development and evolution process that diverse government at the local level, they cooperate and making coordinated plan to deepen their efforts in promoting collaborative innovation. And by 2021, it has been included in China's national planning. And from then on, there are rounds of planning versions for this corridor. The research method involved here include the basic analytic method for the proxy, which is very famous for its application in marrying the innovative activities and outputs. So patents application data in China from 2010 to 2021, which using the Shanghai IP address has served as a monitoring indicator for innovative activities. And the dataset comprises information, includes the patent name, application date, type, address, and IPC classification number to indicate which type of specific R&D activities, especially in terms of technology. In this research, to showcase the distribution of to showcase the diagram of different types of technologies, how they spatially distribute along the corridor. And this is kind of like showcase innovative initiatives in the across the territory space, which may aid the planning for innovation activities and development. And the general trend for the innovation actually were showcased in the figure 2. There are changes in terms of the number of invention patent applications in 9 cities from 2010 to 2021. There were a stage of very slow growth period and entering to the rapid growth stage, and then to a fluctuated stage. Primarily, we can view some like declining trend. There were a total of like over 1.3 million patent data at that time. And here we showcase the 9 cities along the G60 corridors, which accommodates these innovative activities in this figure. This figure shows the innovative technology classes across like 128 different classes. And there are basically 8 sections from section A to section H. Each represents one major type of technologies. For example, section D represents textile and paper related technology, and E represents the technology innovation of fixed constructions. For those, we can see from the figures that most of the patent applications actually were from Section B, Section G, A, and H, and also C. So it indicates a general panorama of the technology innovation, which mainly happened in the field of, for example, operation and transportation, and also physics. As we know that China is now undergoing very intensive technology innovation, and government invest a lot, and also encourage enterprises to innovate in these areas. Okay, in the physics, such as the semiconductors, and some very important technology innovation related to like 5G, something like that. And this is overall proportion of different sections in the total innovation outputs, and different sections, how they actually counts in the total number of patent applications. And for patent classes, G06 actually has developed the fastest for the past few years, rising from the fifth to the first among all the classes. Okay, we know that there are like over 100 classes among all the types of patent applications, and with its proportion fluctuated from 5.18% to 12.93%. So there is actually a very obvious increase of this type of technology. There are also changes of top 10 patent classes we can see from the figure, all the way from 2010 to 2020. And we see the very important or critical position of Section G, which actually emphasize the role of physics, okay, especially those electronic equipment and elements in the country's innovation policy. And if we look further into how different type of technologies perform in different sections and also in different classes, this map may show a relative clear picture for the whole. Okay, we can remember that we actually find that section A, B, C, and G, H actually accounts most in terms of innovative outputs. But actually, within the main section, the classes, different classes actually accounts differently in the whole proportion. We can see that, for example, in section B, the performing, operation, and transportation section, we can see that most of the innovative outputs actually were from like B23 and B65, which is quite related to those up-to-date technology innovation in humanities, in human needs. Okay, this is very important. And also, for example, A61, which falls into the medicine and veterinary medicine, hygiene, this kind of type actually belongs to the human necessities, but within the section, okay, this medicine-related technological innovation were more obvious. Okay, have many more outputs than other type of patent applications. As we've said, B223 is machine tools. Okay, so this kind of technological innovation related to manufacturing innovation actually accounts one of the most in section B. There are also some very typical technological innovation, for example, G06, okay, as we've showcased in the previous picture. It is about calculation or counting, okay, very related to computer technology. And G01 is measurement and testing, also some kind of related to electronic information technology and computer science. This is a basic map. One thing is that China is very strong in terms of manufacturing innovation. Okay, there are many automation technology in this regard. And another thing is that China is trying to support its innovation in semiconductors and related industry. So this lead to the rise or increase of innovation in section G and H. So this is a main picture, the spatial distribution of the 8 main sections. For example, A is about human necessities and H is about electronics. So in terms of the spatial mapping, we can see that, for example, section D actually have a relative even distribution, but A and G is relatively concentrated in terms of spatial concentration and distribution pattern. And we can use like section D to give you an example, is that section D forms a continuous area along Songjiang, Suzhou, Jiaxing, Huzhou, and Hangzhou, with junction of Jiaxing and Suzhou as a core and Songjiang and Hangzhou as a subcores. So there is spatial concentration of this type of activities, but other places they also can accommodate some technology diffusion and transfer from the core areas. But in section G and section H, this type of diffusion and spillover is quite limited in terms of for other areas to accommodate or to undertake some transfer, technology transfer from the main area. So this is very related to the characteristics and features of technology. And this is the top technologies that count most in compared to the other type of two digital code technological classes. And we find that computing, measurement, communications, and electronic are the main areas of patent cooperation. For example, in section G and H, they have the most patent corporations, which means this type of technological innovation actually requires more intelligence input and more intensive knowledge sharing among different areas and talents. And they account for like over 30% and 20% of total patent corporations compared with others. So in conclusion, that over the past 12 years, the number of invention in the 9 cities of G60 has increased very rapidly, and electronic information and biomedicine are very important leading industries in the G60 Science and Technology Innovation Corridor in Yangtze River Delta. And we also look forward more innovation updates in this area. Thank you.